Hey guys, welcome back. Today's notes are 11-4 special parallelograms. Those would be the rectangle, the rhombus, and the square. Yes, we're going to do all those together. All right, so let's get started. You should know by now where you can pause and where you can write stuff down and catch up with me, so I'll leave that to you. First thing we'll go over are the rectangle properties. Okay, as we said before, the rectangle is a parallelogram, so everything about a parallelogram is true about a rectangle. That would be that the opposite sides are parallel and congruent, and that the diagonals bisect each other. Okay, that's all true. The things that are added whenever we make the rectangle is that all angles are 90 degrees, and that the diagonals also are congruent. Okay, so this is the big stuff here. Let's go ahead and mark that then on our rectangle. The angles are 90 degrees. And then the diagonals bisect each other. I'm sorry, the diagonals are congruent, meaning that all these pieces then, the whole entire diagonals are congruent. When they cross then, they're all going to cross and make 4 congruent pieces. So that'll come in handy. All right, so here let's go through our examples. First off, example 1. Here, I'll give you all 3 examples if you want to copy those down. All right, the first example, SU is 10x minus 16. So SU is the whole entire diagonal here. So let me mark that. It is 10x minus 16. All right, RB is x plus 12. RB is just 1/2 of this diagonal here, x plus 12. If that's the case, then find the value of RT. RT is the whole diagonal here. Well, I know my diagonals are congruent, but I only have part of this other diagonal represented. So this other piece will also be x plus 12. So I have to multiply that one times 2 to be able to set it equal to my original diagonals. The diagonals are congruent, so we have 10x minus 16 is equal to twice x plus 12. Or I could say x plus 12 plus x plus 12. All right, let's solve for x from that. I need to distribute. So I've got 2x plus 24. I'm going to subtract the 2x over, so I have 8x minus 16 equals 24. Then it's a minus 16, so I have to add 16 to the other side. So 8x equals 40. And then divide by 8, so x equals 5. Now I want to find the length of RT. Well, if I look up here, RT is there. If x is 5, plug the 5 back in. So 5 plus 12 is 17, and then 5 plus 12 is 17. So RT will be equal to 17 plus 17, which is 34. Double checking out with the other one. If we have 10 times 5, that would be 50. Minus 16 is also 34. So I know I've done that correct. The diagonals are congruent. Next, if the measure of angle 1 is 50 degrees, find the measure of angle 2. Well, check this out. When the diagonals are congruent here, I have a triangle on this side here. And this triangle is an isosceles triangle because those two sides are congruent. So if I turn it like this, you might see it better. But I've got 2 sides congruent here, so therefore 2 angles, the 2 base angles are congruent. So if it's 50 up there, it's 50 down here. And I know the whole entire angle is 90 degrees, so all I have to do is simply take 90 minus that 50 to get 40 degrees right there. So the measure of angle 2 is equal to 40 degrees. Now, I could keep on going here, and I could solve the whole entire rectangle for all the angles. If this one's 40, this is also 40. Subtract that from 90 to get 50 up top. It's going to look like over here. So 50, 50, and then 40, and 40. And then if I want to find the angles inside, which I do sometimes, if I have 50 and 50, that's equal to 100. And I have a triangle here, so what's left over is going to be 80. There's 80 there. There's going to be 100 there because those are supplementary. And then vertical angles, so 80 and 100. So I can solve for all the angles in the triangle, or I'm sorry, rectangle if I know just one. All right, last example. I am not going to solve this one for you because if we notice, RU is 3x minus 5. It says UT is y minus 25. RS is 10 up top. And then ST is 4. All right, what this does is the exact same thing as a parallelogram. The opposite sides are congruent, so I can set them equal to each other and solve. Now, if you want to go through and solve these, you should get x is equal to 3 and y is equal to 35, so you can double check. All right, next we have our rhombus. The paper keeps going. There we go. All right, rhombus properties. Like we said, rhombus is just a parallelogram. So we have a couple things that are left over from the parallelogram. The opposite sides are parallel and congruent still. The opposite angles in this case are still congruent, like our normal parallelogram. What's different though is that all sides are congruent. We should know that about a rhombus. All sides are congruent. The diagonals still bisect each other. But now, especially for a rhombus, the diagonals are perpendicular and they bisect the angles. So two more things that are added with the rhombus. Okay, so I want to mark that here on my rhombus here. If the diagonals are perpendicular, that means they make a right angle in the middle there, and they bisect the angles. So these angles are split in two. These angles are split in two. Angles there and angles there. All right. The diagonals also bisect each other. So this one is congruent to this one. That piece is congruent to that piece. All right. Just a reminder of that. All right. So here's my rhombus examples if you want to copy these down. First off, it says Fs is equal to 12. Hi is equal to 16. Find the perimeter of fish. Fish is the rhombus here. All right, if Fs is equal to 12, this whole entire thing here, and it was bisected, that means each piece will be 6. If Hi is equal to 16, the whole entire diagonal there, that means it's cut in half as well, the 16, so we have 8 and 8. Now the goal here is to find the perimeter of fish, so I need to find the outside here. Well, if you look closely, you have a right angle, and this is a right triangle. If I have two legs of a right triangle being 6 and 8, I can find the third angle by using the Pythagorean theorem, but you should also recognize that as being a Pythagorean triple. So this side will be 10, 6, 8, 10, right? 6, 8, 10 here as well. I have a 6, 8, 10, and I have a 6, 8, 10. Again, all sides are the same. So if I want to find the perimeter, I just have to do the 10 times 4, which would be simply 40. All right? Next example, if Fi equals 6x plus 2. So this is a separate example. Fi is no longer 10 for this one. It's 6x plus 2. Si is 8x minus 4. And it wants me to find FH. FH over there. Well, notice all these sides will be congruent, so really I have to just solve for one of these sides here, and then I'll know the other one there. All my sides are congruent, so I can say 6x plus 2 is going to be equal to 8x minus 4, and then solve for x. If I subtract 6x over, it's gone from here. I have now 2x minus 4. If I add 4 to this side, I have 6 equals 2x. Now I divide by 2, so x is equal to 3. To find FH, plug that 3 back in for one of these x's here. 8 times 3 is 24, minus 4 is 20. To double check that, 6 times 3 is 18, plus 2 is also 20, so I know I've done it correctly. Now FH will be equal to 20 degrees. Last example. It says the measure of angle FIH is 56 degrees. Find the measure of angle IFH. All right, I'm going to label up here. It was 56 for angle FIH, and then find the measure of angle IFH. I want to find this whole thing here. I'm going to redraw this parallel of this rhombus down to the bottom so I can work a little closely, work with a clean copy. Okay, if that was a rhombus, I had this diagonal going through here to get 56 degrees there. And I want to find this angle here. Well, as we marked and as we talked about, this diagonal bisects this angle. So each piece is equal to 56 degrees. Now we go back to something we talked about all parallelograms, is that the consecutive angles equal 180 degrees. So both these angles together will be equal to 180. So all I have to do is find out what's left over. If I take the 180 and I subtract the 56 and 56 together equal 112, find out the remaining. Well, I can do some mental math here. To go from 112 to 120, I need to add 8. Now if I'm at 120, I need to get to 180, I need to add 60. So 68 is what's left over. Same thing as subtracting 180 minus 112. So 68 degrees is what's right here. All right, I can go around and I could cut that in half with the other diagonal to get 34 and 34 on both sides and find all the angles of the rhombus as well. All right, that's it. Oh, notice that we don't have any special things for a square because a square is comprised of both a rectangle and a rhombus. Put them together, all the properties work the same. So we have no examples for that. You're welcome. See you guys in class.